All right, this is the last section of review on evaluating logs. So this is a little longer, but the examples should go by fairly quickly once we get into the process of it. So pause this video here and write down these examples, leave a little bit of room for the work and answer, and then resume when you're ready to go. So we're evaluating logs. Okay, we're going to use the ideas of inverses again to help us manipulate the problem a little bit to hopefully get the correct answer. So when we're evaluating, we're again just pretty much computing and finding out a numerical value for what it represents. So one thing we want to first recognize is what this actually means. So log base A of B literally means this. This is what it's asking for. Okay, so this means A to what power equals B. So A, the base, to what kind of power gives you the value of B, the number that's right above the log base A. So that's what we want to kind of think about as we're doing all these problems. Now, some of these problems are a little bit more challenging to answer this problem with, so there is a process or procedure that I follow to help us get the answer, but this is pretty essentially what we're asking ourselves and what we're trying to answer every time we're trying to do logs. All right, so this first one is log base 5 and 125. So just like this example that I was talking about on the top, A to what power equals B? Well, this example would be 5 to what power would get us 125, right? So some of us may already know that answer. You know what power that would be to get 125, and the answer should be 3. Okay? So that's an easy answer to it. 5 to the power of 3 equals 125. Right? That's essentially what we're trying to answer. Well, what if we can't do that? What if we don't know power of 5 to the power of 3 is 125? Well, the other way to do it is you want to create a common base between this number at the top and the log base 5. So that is what we're going to try to do as a procedure. We're going to try to create a common base. So when we know, well, in the previous video we talked about having a common base between exponentials and logs, and when we apply them to each other, they cancel each other out since they're inverses. So we're gonna try to use that idea to help us cancel out this log, so we're just left with our answer, right? So right now, 125 and 5 are not the same base. This is 125 to the power of 1. This is 5. So what I want to do is I want to convert 125 so that it's in terms of base 5. Okay? So I'm going to write log 5 because that's what's there. And then 125, I'm going to change to 5 and then to some power. So you would use a calculator, you would just trial and error if you need to, but you would think, what to the 5 to the power of what is 125? You're pretty much having the same line of thought, but you're going to figure out on your calculator, hopefully, that it's 3. And what we can do here is, just like before, the log and the 5 cancel out. And what you're left with is your answer, which is 3. Okay, so that is a procedure that I would follow if I really, really, really can't find a power for it. Okay, so create that common base and then cancel out the bases so you're left with the power pretty much here as your answer. Okay, so we'll try that for the second one. Log base 3 of 27. Some of you can already do that, but again, we want to ask ourselves, log or 3 to what power equals 27? 3 to what power equals 27? So again, with easier ones, this one, you should know it's 3. But let's see how we can do with the procedure. We do log base 3, and we rewrite 27 to have a base of 3. So we'll write 3. 3 to the power of 3 is 27. So I'm rewriting this 27 as 3 to the power of 3. Log base 3 and this exponential of 3 cancel out, and the power is your answer. So it's just 3 again. Let's look at an example with a fraction. We haven't done much of this, but it is something that we need to be familiar with. But it's negative powers. Okay, so again, we're going to do the same thing here. We want to change this 1/8 to have the same base as this log, which is 2. So I'm going to change it to log base 2 of 2 to the power of blank. Now, 1/8, if I want to have a, if I want to change it to a non-fraction, meaning like I want to bring this 8 to the top, I can change it to 8 to the power of -1. Having a negative power pretty much switches it to the other side of the fraction. So I can rewrite, here, let me scrap this really quick. I want to get the same base first. So 8 is more familiar than 1/8, but I'm going to change 1/8 to 2 to the power of 3, because 8 is the same thing as 2 to the power of 3. And then now I'm almost there. I almost have that base of 2, but this is in a fraction. I don't want that. I want to have have no fraction. So what I can do is I can bring this up to the top and change the power of 3 to a -3. So this is actually 2 to the power of -3. Okay, so 1/8 is equal to 2 to the power of -3. And that's going to come up pretty often. So get used to seeing that negative power, get used to converting fractions to negative powers. But here I have my base 2 and this log base 2 cancel out, and my answer is -3. Okay, let's continue on. Log base 3 of 1/9, same thing, a fraction. So I want to change 1/9 to have a base of 3. So 1/9, 9 can be written as 3 squared, and I can convert that fraction into a 3 to the power of -2. All right, so 1/9 is the same thing as 3 to the power of -2. I'm going to rewrite that. So log base 3, 3 to the power of -2 equals -2. 3 and the log 3 cancel out. Okay. Okay. All right. These are two other examples of something that's not a whole number, so or just a little different than what we're used to. But these two examples here are going to represent fractional exponents. So I'm going to write these actually. This is an example of a negative exponent. This is a negative exponent because there's a fraction. And you're going to see how these two examples are going to produce a fraction exponent. Okay, so log base 25 of 5. If we're answering this question that I've been keeping in mind, 25 to the power of what gets you 5. Okay, well, I'm not adding or subtracting, right? So I can't just subtract 20. I have to think of a power, right? Now, if I do fractional powers, that's actually the same thing as square rooting or rooting something, right? I can cube root, square root, fourth root with fractional powers. So you can think of like a root. What root can I square root or like cube root 25 to get 5? Well, I can do, 25, square root of 25 equals 5. So what I can rewrite 5 as, so that it has the same base as this log, I can rewrite 5 as square root of 25. Right. Okay, but I need an exponent. I don't know what to do with that root. I can't cancel this out because this is a square root of 25. This is just 25. So how do I rewrite that as a power? Well, square root is the same thing as a power of 1/2. Okay, so again, square roots are the same thing as power of 1/2, a fraction power. So now that I have the same base of 25, I can just cancel those out, and my final answer is 1/2. Right? Same thing for the second one. I have a base of 27, so I need to change 3 to be a base of 27. Okay. So I have to think of what root I can take for 27 so that it turns into a 3. And it's not square root, but if you do cube root, that will give you 3. If you can try to put in the calculator, you can try to find the cube button. It's under math, I believe, in your calculator. But it's a cube root of 27 will get you 3. Which means I can change that into 27 to the power of not 1/2 this time. It's cube root, so it's 1/3. Okay, so 3 is the same thing as 27 to the power of 1/3. So I'm going to write log base 27, 27 to the power of 1/3. I'm going to cancel out the log and the 27, and my final answer is 1/3. Box all these answers here. Okay. So 2 new things to remember. Negative exponents should be used when you have a fraction, and when you have a fraction exponents, that's when you have like roots or square roots or cube roots, any root. Okay. All right, 2 more examples here. A couple more. These go by quick though. We're dropping in some common logs, and all of these can be reasoned out with that question I had. What something to the power of what power equals b? Well, let's think about that. 10 to the power of what? What power do you need so that it equals 1? Well, this is a very common thing that we do use. Anything to the power of 0 equals 1. Okay, anything to the power of 0 equals 1. So I can think of this as 10 to the power, log base 10 of 10 to the power of 0 equals 1. Right? Anything to the power of 0 equals 1. So that's a good piece of information to keep in mind, because that will help in the long run. Okay, so I'm going to cancel out these log base 10s, and your answer is just 0. Okay. Same thing here. 7 to what power equals 1? Well, we just said anything to the power of 0 equals 1. So this is also 0. And we can also think of it as log of 7. 7 to the power of 0, that's the equivalent of 1. So the logs and the 7's cancel out, leaving us with 0. So that's easy enough. All right, these next two, there are no bases available. So I know from a previous video that if there is no base shown, I know it is called common log, which means it's a base 10. So if you really want to, you can write the 10 back in there, but you're pretty much going to want to convert that 100 to be a base of 10. So log, common log, 10 to the power of 2. The common log and 10 cancel out, so you just have 2. Okay, again, this can be rewritten as log base 10 of 100. Right? Same thing, another common log. There's no base here, so it's a base of 10. Common log. So 10 to what power equals 10? 10 to the power of 1 equals 10. So your answer is just 1. Okay. Okay, last few examples here. ln of 1. Well, ln again is just another frequently used log. It is a base of e. This is base e, natural log. Right? So we're thinking e to what power equals 1. So again, if it's anything to the power of 0 equals 1. So I can write this as ln of e to the power of 0, and the ln and the e will cancel out, leaving us with 0. So next one, ln of e. What happens here? Well, the ln and the e cancel because you have a base of e here. But since e is technically a power of 1, ln of e is just going to be 1. The ln and the e will cancel. Right, so ln and e, very, very nicely used here. For these last two, these can be very simple. The ln's and the e's cancel out, and you're left with 23. ln and the e cancel out here, and you're left with -6. Okay, so these are all the problems, all the different ways that you can evaluate a log. You again have just the normal way of just figuring out a to what power equals b. You have those negative exponents you need to keep track of when you have fractions. You have fraction exponents when you have square roots or cube roots or any root. And then you have these common logs and natural logs that are pretty simple once you can, get the hang of it. Right. Oh, and also when you have log of anything to 1, it's always 0. If you look at these problems, this one was 0, this one was 0, this one was 0. So when you're doing log or e of 1, it is always 0, no matter what base you're using. Right? So replay the video if you need to, and that finishes all the review videos. If you are ready to move on, I will have another one after this.